a common assumption. When we hit the shortest day of the year in December, we expect the coldest days to follow immediately. But have you ever noticed that the coldest days tend to arrive in January, weeks after the darkest day? Let's break down the science behind this fascinating phenomenon. The reason the days get shorter and longer throughout the year comes down to Earth's axial tilt. Earth is tilted 23.4 degrees relative to its orbit around the Sun. This means in December, the northern hemisphere is tilted away from the Sun, leading to the winter solstice, the day with the least amount of daylight. In June, the northern hemisphere is tilted toward the Sun, bringing the summer solstice, the longest day of the year. So the darkest day of the year falls on or around December 21st. But this is just part of the story. If we start gaining daylight after December 21st, shouldn't temperatures start warming up right away? Not quite. The key reason is that Earth takes time to cool down and warm up. Just like how your house doesn't immediately get cold when the sun sets, the Earth doesn't hit its coldest point right away. Instead, heat from the summer months lingers in the ground, bodies of water and atmosphere delaying the coldest period. Think of it this way. Imagine you put a hot bowl of soup in a cooler room. Even though the room is warming up, the soup will continue losing heat for a while before it stops cooling. The same principle applies to Earth. Even though daylight starts increasing in late December, the heat being lost still outweighs the heat being gained until mid to late January. That's when we typically hit the coldest days of winter. While weather patterns vary from year to year, the average coldest time of the year in the Northern Hemisphere is in mid to late January. This delay is called seasonal lag, and it happens because Earth stores heat from previous months and gradually releases it. The oceans, which cover 70% of our planet, take time to cool down and influence atmospheric temperatures. Snow-covered surfaces reflect sunlight, keeping temperatures colder even as daylight increases. Now, if we were to view Earth from space, we'd still see a bluish tint over the planet even during winter. That's because Rayleigh scattering, the process that makes our sky blue, still occurs. However, space itself remains black because there's no atmosphere to scatter sunlight. It's a great reminder of how Earth's atmospheric properties influence what we see and feel on the ground. So, while the darkest day of the year happens in late December, the coldest days typically arrive in mid to late January. This delay is due to Earth's ability to store and release heat over time. Just another example of how nature doesn't always follow our expectations. Next time you're bundling up in January, remember, the days may be getting longer, but winter's grip takes a little more time to let go. That's your weather insight for today. Stay warm, stay informed, and as always, keep an eye on the sky.